Hello everyone. Welcome to Monitor the World, Meaningful Metrics for Kubernetes Applications and Clusters. My name is Nick Turner. I'll be your presenter today. A little bit about me. I'm an SDE at Amazon EKS, and I enjoy spending time outdoors. So let's get into the agenda. Today we're going to be talking about monitoring. We're going to go over the state of monitoring today and some methodologies that a lot of folks use in monitoring their Kubernetes clusters or applications in general. We're going to talk a little bit about tools, especially Prometheus, a little bit about CloudWatch and the various components in a Kubernetes cluster. We're going to talk about the metric sources there and what metrics these sources provide, and the key metrics that you really want to make sure that you're monitoring in a Kubernetes environment. We're going to touch briefly on correcting problems, and then a little bit about the control plane at the end and monitoring control plane. And that will do it. So moving on to monitoring microservices. So why do we monitor? Well, it's pretty self-explanatory. We're looking to detect problems so that we can fix them. And that's really about preventing outages. If you tried to monitor a Kubernetes cluster with just node and load balancer metrics, you're going to have a bad time. And of course, we're pretty nosy. We want to know what's going on in our cluster. And so monitoring is important, but it's also difficult. And it's even more difficult in a microservice Kubernetes environment. And I think the biggest reason for that is because there's so many different things that you can monitor that selecting the right metrics can be really difficult. And containers themselves are difficult to monitor because they're generally more transient than your normal workloads, especially in Kubernetes, where you're not guaranteed to have any one container running on any one instance. So the question is, how do we approach this problem? And there's definitely been a lot of really smart people who have thought about this. And two of my favorites are the use method that was introduced by Brendan Gregg and the red method introduced by Tom Wilkie. And they sort of solve two different problems. So the use method it's for things that you can consider resources. And I would consider resources hardware or infrastructure components of your cluster. They're used by your applications and they can be overused. You can measure utilization on resources, which is an average of usage over time. And you can also measure saturation, which is more of an instantaneous measure of usage. So you might think of saturation as some sort of queue, like a queue of processes waiting on a CPU, or a queue of processes waiting on disk, whereas utilization is the total time, maybe throughout a minute, how much time a process has used the CPU. So moving on to tools, the great thing about monitoring Kubernetes is that there is a wealth of tools available to us. The community has produced a ton of really awesome, really powerful monitoring tools. From Prometheus, we have Prometheus is a really mature project. originally based on Google's Borgmon. It has some similar concepts, and it's really widely used in Kubernetes. Most components in Kubernetes export their metrics in a Prometheus format so that you can consume them if you deploy Prometheus into your cluster. CloudWatch is also a really great tool for monitoring clusters. And the metric server, the node exporter, the node problem detector, kubestate metrics, and cAdvisor are all components in the cluster that export or expose metrics that we can use. And then Kibana is a good tool for visualizing your metrics. I'm not going to talk as much about logging today, but FluentD and Elk and CloudWatch logs are all great tools. And for alerting, you can use CloudWatch alarms and Prometheus Alert Manager. And there's a ton more projects that are out there, third-party tools that are really great. So Prometheus itself is a very comprehensive open source monitoring framework. It has a really rich querying language. And one thing that's interesting about it is it's a pull-based model. So you have microservices running in your cluster. They expose a metrics endpoint. And then you configure Prometheus to pull metrics from the endpoint and store it, and then you can visualize it. Prometheus has a sort of rudimentary visualization endpoint, or you can hook up Grafana or something like that, or export them to CloudWatch and visualize them there. And so another really great thing about Prometheus is that it has a multi-dimensional data model, which means that each metric value that you store is going to have a name and then a bunch of key value dimensions attached to it. And this gives you a really powerful way of querying the data, as we'll see later. And then, of course, Amazon CloudWatch is a metrics, logging, and alerting framework. What's really nice about CloudWatch is that it's fully managed by Amazon. Highly available. You may want to export CloudWatch metrics into Prometheus or vice versa. And I tend to want to send some of my most important metrics into CloudWatch just in case something happens to my Prometheus deployment in my cluster. Then I still have those metrics and those alarms in CloudWatch to tell me that something's wrong. Okay, moving on to metric sources. So this is where it gets fun. Kubernetes has so many different metric sources and places where we can derive metrics from. The kubelet itself, which is the daemon that runs on each node, exposes a few core metrics. These are related to pod and node metrics, so CPU and memory for pods and nodes. And then, so that actually uses an embedded cAdvisor, but if you can run your own cAdvisor along with that to expose deeper container metrics. And then we have the node problem detector and the node exporter and kubestate metrics, which I'll get into later. So the node exporter is it's an open source project. You can find it. It's under the Prometheus organization. It exposes mostly node hardware and OS metrics. It can be run as a daemon set, but it requires access to the host file system. And it exposes really rich metrics, CPU, memory info, metrics about file system, load average, disk statistics, all kinds of networking metrics, boot time. If you are on IPVS, it exposes metrics about that. So lots of really rich metrics that we can use there. And then we have the node problem detector. So the node problem detector is another open source project under the Kubernetes organization, and it exposes problems up the stack with events and node conditions. And events are basically temporary problems that are going to get resolved that you can see in the normal Kubernetes kubectl get events. And then node conditions are something that it's going to put on the node that's a permanent issue that you can then, you can use to prevent scheduling or any kind of logic that you want to then diagnose or remedy the problem. And then I already spoke about CAdvisor a little bit, but this gives you really rich container level metrics, specifically resource isolation parameters and historical resource usage. It can be run as a daemon set as well, and it's also linked inside kubelet. But the linked version inside kubelet only exposes the core metrics. So if you want those rich metrics, you're going to have to run it separately as well. And then we have kube state metrics. So the difference between kube state metrics and, for example, the node exporter, kube state metrics generates all of its metrics from the Kubernetes API, whereas the node exporter is actually deriving those metrics from the operating system itself. So kube state metrics is really great for getting rich metrics about the objects that are stored in Kubernetes itself, like deployments, daemon sets, pods. But the problem is that it can be very resource intensive. So you have to be careful if you have a very large cluster. Definitely watch the memory required by kube state metrics, because it's really taking the entire state of the Kubernetes cluster and storing that and generating metrics off of it. So you can see some example metrics like the deployment status replicas, available, unavailable, updated, and it has similar metrics for daemon sets, pods, replica sets, nodes, all that kind of stuff. And so another source of metrics is the metrics server itself. Although it's not actually the source, the kubelet that runs on each node is generating the metrics that go to the metrics server. And the metrics server really has only current values of these core metrics. So it stores CPU and memory information for pods and nodes, but it doesn't give you historical metrics. It's used by the horizontal pod autoscaler to make decisions, and it's run as an aggregated API server. So it's not going to give you the deep metrics that you might be looking for diagnosing issues, but it's definitely necessary if you want horizontal pod autoscaling in your cluster, which is highly recommended. So, of course, you're also going to be running your own applications in the cluster, and it's really easy to instrument them with a Prometheus Metrics endpoint so that you can scrape the endpoint of your application just like you're going to be scraping the other components of your cluster. So Prometheus exposes or gives you the ability to expose 4 different metrics types. There's the counter, which is just a monotonically increasing number. You have a gauge, which can go up and down, and it's kind of like a speedometer. And then you have a histogram, which is it's a sample of observations, and they're divided into configurable buckets on value. And then you have a summary, which is very similar to a histogram, but it's split into quantiles rather than values. The really nice thing about Prometheus client libraries is that they're available in pretty much any language that you'd be interested in. The official client libraries are Go, Java, Scala, Python, and Ruby, but there's a lot of unofficial third-party libraries as well. So just to show you how easy it is to instrument an application with Prometheus, this is almost a complete Go program, and you can see how little code it is. This is a HTTP server. We're listening on port 9000. We're exposing a metrics endpoint, and we're handling requests to /store as well. And this, if you include the prom HTTP library, all you need to do is wrap the handler function with this instrument handler counter, for example, if you wanted to create a counter. And then Prometheus understands that it's HTTP, and it takes care of counting the request codes or statuses, and it's, as you can see, quite easy to set up. So there's also a CloudWatch exporter project which allows us to export CloudWatch metrics to Prometheus, and it does translate all of the exported metrics as gauges because that's closer to the native CloudWatch type. So moving on into our key metrics, what we really want to pay attention to in our Kubernetes cluster. And so remembering back to the methods that we touched on, so from the use method, we were focusing on resources. So if we're looking at resources in a Kubernetes cluster, what even is a resource in a Kubernetes cluster? There's the obvious ones, right? There's disk, there's CPU, there's memory, network interfaces, and I would include load balancers here. You can think of load balancers from a use perspective because you can measure utilization. Load balancers can become saturated. But you can also think about it from an application perspective because you can measure things like request status, latency, and rate at the load balancer level. So for CPU, there's a couple metrics that we would definitely want to consider, utilization and saturation. And the utilization metric is the CPU use time, essentially. And saturation would be something along the lines of CPU load or throttled time over total time. They're definitely useful cluster-wide. If I'm looking at my Kubernetes cluster, I'd want to know if overall the CPU is overutilized. If I'm at 60% CPU, 70% CPU or higher, then I'd want to know. And that's generally where you hook up something like the cluster autoscaler to watch the cluster-wide metric and then scale up as your resources are overutilized. But CPU specifically is also useful aggregated across pods and containers. So here's some query examples just to give you a sense of what a Prometheus query looks like. So the container CPU usage seconds total is one Prometheus metric that has to do with CPU, and as soon as you install Prometheus and look at if you install CAdvisor and the node exporter, you're going to see just how many of these metrics that they expose. But so this one specifically, container CPU usage seconds total, is a counter. So that means we need to take a rate of the counter so that we can get something that actually looks useful. So here's an example of taking the rate of the counter and looking at it's the 1 minute rate of the usage. So that would be a good way of looking at CPU utilization for, in this case, it's a specific container. And then we can aggregate by container type or by pod, or even view it at the cluster level. So memory, of course, is another key metric. Utilization is one way of thinking about memory utilization is just available over total. And so saturation is a little bit trickier with memory, but swapping or paging is one way of thinking about it. Although generally you really don't want your cluster to be swapping. You should probably turn off swap. But if you have a way of measuring paging, then that could be a way of looking at saturation for your for memory in your Kubernetes cluster. And memory is another metric that's useful cluster-wide and then also aggregated across pods and containers. A couple of query examples for memory. We have the cluster utilization. So it's, again, just memory available over the total memory. And then below that, we have an example of node utilization. So disk is also important. And there's a couple different ways of looking at utilization for disk. I/O time, and then disk capacity. And then for saturation, we would be looking at something like the queue length of the disk. So processes waiting to write or read from the disk. And so disks, in a Kubernetes cluster, you have a disk per node, so you're going to be looking at that. But then you also have disks like persistent volumes that pods have claimed throughout the cluster. So you'll want to be monitoring those as well. And as we'll touch on later, you'll want to be looking at etcd and its disk usage. And so here's a disk query example, which is node disk utilization. So you can see the metric node disk I/O time milliseconds, which is why we divide by 1,000 at the end. And so the I rate, that calculates the instant rate, and you can contrast it with the normal rate function in that it doesn't it's a little bit faster to pick up on changes. So if you're looking at a graph with I rate, it's going to be spikier and give you a more exact view of what's happening in the moment, because it takes fewer data points into consideration than rate does. And so this is a fun one. If the comment wasn't there, I think it would probably take you a little bit to figure out what's going on, but it's actually this is a metric that, an expression that is used in an alert that will alert you in 24 hours if a disk is going to be full. So it does a linear prediction, and then using Prometheus Alert Manager, you get an alert 24 hours before your disk is predicted to be filled up, which I think is pretty cool. So network interfaces. You can look at a number of different metrics with network, but I think the most useful is trying to figure out a utilization metric, which the best that I've come across is looking at your throughput and then dividing it by what you know your instance type bandwidth is. So, for example, in AWS, depending on what instance type you have a different total bandwidth. So you can get a good measure of utilization just by dividing throughput by bandwidth. And this is useful definitely per node. You might be interested in it cluster-wide, depending on how network intensive your applications are, but you might not be. And then you also, again, might be interested aggregated by pods, but it really depends on what kind of applications you have running in your cluster. And then, as I mentioned before, some metrics for load balancers. So utilization, pretty easy. Requests per second, pretty straightforward. And then on Amazon, like ELBs, you have a saturation measurement of surge queue length, which can be pretty useful. You can see at any moment in time if you have requests pending at the load balancer. And that's really only useful per load balancer. If you have one load balancer per application, then you can correlate the application to the load balancer, or maybe you can't. So then moving on to the red method, which is the method that's generally used for applications. So most of your applications running in your cluster, you're going to want to look at requests. You're going to want to look at request rate, errors, and duration. And this will give you a pretty good feel for how healthy your application is. If you can tell a lot about your dependencies if your duration is high, and implementing some kind of tracing, some kind of request tracing into your applications is going to help you figure out which dependency is taking a long time or which resource. So the other metrics for applications that can be useful, I've found in Kubernetes, is actually taking a sort of a saturation approach to them and looking at what I guess this could be utilization, but looking at what your total number of pods that you have versus your available pods. So if you have a application that crashes frequently, which hopefully you don't, but you definitely want to keep track of how healthy it is, especially if you have spikes in traffic. And then an error metric would be pod restarts. You definitely want to keep track of that for your critical applications. Well, so now that we have this wealth of information and we've pared down some of these metrics, we need to think about what to do when we do have a problem and how do we correct it. Ideally, every problem that you have, you could automate the correction for, but that's probably not going to happen, at least at first. But there are some easy wins that you can implement in your Kubernetes cluster. So the cluster autoscaler and the horizontal pod autoscaler are the two things that I would start with first. The cluster autoscaler is going to increase and decrease your nodes, the number of nodes that you have. And then the horizontal pod autoscaler is going to do the same for your applications themselves. So depending on your application, you'll want to scale on different metrics. But CPU is always a good metric to start with. And then if you can, this also depends on your applications, but detecting an unhealthy node is something that you might want to try to do. And there's a couple, obviously the node problem detector that we talked about is one way to do it. Another way that I found to be fairly useful is to deploy a canary daemon set. And that's essentially an application that it makes the most sense to run as a daemon set. You basically everything, or the most important things that your other applications do, you might have the canary do. So for example, if you're going to be making a request out to S3, then you might have your canary do that as well, just to make sure that when a node comes up, there aren't any issues with it. Maybe you're deploying to a new region that you haven't deployed to. The new region doesn't have the containers in your registry, and maybe you have them in ECR, and you could have a canary that detects that in some way, or something similar. So, and then another correction that you'll definitely do at some point is rolling back a deployment, which Kubernetes makes really easy. So that's most of what I have for the data plane. I did want to talk about the control plane a little bit. Obviously, if you're using EKS, you don't have to monitor the control plane yourself. But if you have a cluster set up with COPS or something similar, then you will want to be conscious of what is going on in the control plane and how it's performing. So the components of the control plane, we have the API server, we have etcd, we have controller manager, scheduler, and then you might be running other components. You might be running an external cloud provider. You might be running certificate controllers, or various other things. You might include the metrics server in your control plane, some of your monitoring framework there. There's a lot of different ways you can set it up. So it's actually, monitoring the control plane is very similar to monitoring your applications. The most important thing I think you should do is just make sure that your control plane pods are healthy, and the quickest way to do this is with checking the health C. And but you also want to use the methods that we spoke about. So especially the red method, you want to look at, for example, for the API server, you want to look at request rate, latency, and then errors. And rather than, we'll talk about monitoring etcd a little bit. So for example, instead of monitoring latency at etcd, I'd rather monitor it at the API server, because that's actually what I care about. I care about latency at the API server level, but I don't really care if etcd experiences a spike in latency that I don't notice. So another good thing to check as a sanity check is just making sure that your running pods is equal to your desired, so you don't have a bunch of, you don't want your controller manager to be crash looping and you to be not aware about it. So pod restarts and just checking the number of running pods. And so something that can run into issues as you have larger clusters is your scheduling. Things like scheduling can slow down. So you might want to watch, for example, pod state changes, or the time that your pods spend in pending, and that can give you a good feeling for whether or not your scheduling is slowing down as your clusters are scaling up. So etcd specifically, you might want to take a look at your disk sync duration, and that's because longer disk sync durations can lead to leader elections, And leader elections can cause unavailability. And then you want to check the metrics for whether or not you have quorum. There's a leader metric. So if the leader metric is 0, then the cluster doesn't have quorum. And that means that it can't accept writes. So that's going to affect your availability as well. You'll definitely want to start etcd with experimental, well, you might want to start etcd with the experimental corrupt check flags, because that'll help you avoid disk corruption. It is possible that if you don't use these, that etcd will start with corrupt data and then start sending it out to the other instances, and your whole cluster will then have corrupt data. So you definitely want to avoid that. So again, latency, I would just measure the API server, but you do want to measure disk capacity, and occasional compaction might be necessary depending on your usage of etcd. Okay, and so now I'm going to go into a quick demo. Okay, so now we're going to switch over to a quick demo. And I wanted to show a really easy way to get up and running with Prometheus. And that's by using the Prometheus operator tool by CoreOS. And they have a great contrib section called Cube Prometheus, which we can take a look at. So Cube Prometheus is a collection of configuration that's written in JSONIT, which is a superset of JSON. It's a config language, and it can be used as a library. And there's actually a tool called the JSONIT bundler, which allows us to install libraries, and then the JSONIT compiler takes all of this config and turns it into JSON, which we're going to use to configure our the Prometheus and some of the other things that are running in the cluster. So JSONIT, this is the language that we'll be using. And this is the bundler, which is the package manager, which I've already installed. So if we switch over, I have set up, I've cloned the Cube Prometheus, which is inside the Prometheus operator GitHub repository. And you can see in contrib you have Cube Prometheus. And so there's the docs, there's some examples in here, and you can refer to, they have a really in-depth getting started guide. So you can definitely check that out. But basically what you want to do is create another directory where we're going to put our configuration in. So I've created nix cube Prometheus, and the majority of our configuration is actually just going to go into one file, which I've called nic.jsonit. So what this does is it uses the libraries that they've created, which are bundled by the JSONIT bundler, and we're going to import those, and then we're going to put some of our own configuration on top of it. So you can see us actually importing the Cube Prometheus libsonit up here, and then we have we can add our custom configuration into the, and what this does is it actually turns JSON into almost an object-oriented language. So we can add any pieces of config that we want, and it'll overwrite the JSON that would be generated by the Cube Prometheus library. So let's take a look at what we have right now. Okay, so I have a EKS cluster. So you can see the describe cluster for the EKS cluster, and then I'll take a look and see what's inside of it right now. Okay, so I have a couple applications running in it. You can see everything in the kube system namespace. I have CAdvisor running on each node. A couple, like a Redis deployment, an application that I've deployed that I've called SuperDuper. We have kubedns. We have the metrics server. So now let's look. We're inside of my kube Prometheus directory, and you can see my nic.jsonit config file. So there's a convenient build script here that runs the JSONIT command to compile the JSON, so we're going to do that really quick. Alright, so it looks like it finished. So now let's see what it did. It actually generated a manifest directory. And this is part of the build command converts all of the JSON that JSON generates into YAML. It's a little bit easier to work with. If you wanted to take a look at it, see what it generated, it's a little bit easier to read. But I wouldn't recommend editing the YAML itself. I'd recommend editing the JSONIT because that way you can regenerate it and you don't have to worry about overwriting something that you've modified. So let's take a look at what we have so far. So the way that Prometheus scrapes its endpoints of services that are running in the cluster with Prometheus operator is that you actually set up Prometheus service monitors, which are, so we'll take a look at one of them. So if we look at a Prometheus service monitor for the API server, you can see that the custom resource definition is monitoring.coreos.com v1. It's a service monitor kind, and it has a little bit of configuration. So endpoints, here there's a little bit more. There's a bearer token file. There's going to be, we have to make sure we can authenticate to the API server. So now let's go ahead and install this into the cluster, and we'll see what we get. All right, there we go. That worked that time. So let's take a look at what's running in the cluster now. So we can see that it's created a monitoring namespace, which has kubestate metrics, Grafana, Prometheus operator, and then somewhere there will be Prometheus itself, Prometheus Kates here, and still all of the applications that I was running before. So right, so now we're going to connect to the Prometheus that's running in the cluster and just see what it has. So it's going to be available at, oh, before we do that, actually, we have to port forward. Since I didn't set up any services, the easiest way to make Prometheus accessible is to port forward the services. So we'll take a look at that really quick. It's just a script that's going to use the kubectl command to port forward for each of these services. So we'll do that really quick. There we go. And now I can go over to my browser and take a look at the Prometheus dashboard. So if I want to see what metrics are available, it actually gives me a list, a drop-down menu of everything that it has collected, which is really useful if you're not sure. I mean, there's so many metrics, so just looking through this to figure out what is actually available can be really helpful. So one thing that I want to see is that I've set up this application that I call SuperDuper, and I've added some metrics to it. So let's take a look at that really quick. So I have some custom metrics, and I've also added around my store endpoint, I've added the prom HTTP instrument handler counter. So I'd like to see what that does for my for the store endpoint, and see if we can see those metrics in the we can see that Prometheus is collecting those metrics. So if I just search by prom HTTP, we should be able to find, so we have prom HTTP metric handler request total. We have prom HTTP metric handler requests in flight. So let's take a look at the request total, and we can look at the graph. And so it just started collecting. So we can see the requests that I've been making on, for example, Prometheus itself would probably be visible here. And you'll notice that the metric is, since it's total, it's a counter. So it's going to be increasing unless Prometheus restarts, then it'll start back at 0, but it will continuously increase. It will never decrease. So to make it useful, we'll probably have to look at a rate. So let's take a look at the rate here over 1 minute. And so now the lines have flattened out, and we can see the continuous rate of requests for each of these. But it's kind of hard to tell what everything is. So I'm going to adjust the time frame here and zoom in a little bit. So we'll look at 15 minutes. And then I'm going to do a little bit of aggregation. So I'm going to sum by, let's try service and see if that shows us anything that we want to see. Okay, so it looks like we do see Prometheus Gates, we see Node Exporter, and we see Alert Manager. So if I can connect to the SuperDuper application that I have running, I'm going to send a couple requests at it and see if I can really spam it a little bit. Okay, so we can see that we can see 3 services here that are emitting metrics, but I want to see the metrics from the SuperDuper service that I've deployed in the cluster. So let's see how we can do that. We're going to need to add some configuration to the nic.jsonit file. So I'll go ahead and uncomment that out right now. And basically what this is doing is it's concatenating a new object here with something called, it's an object in the libsonit library called Prometheus. These double colons here just mean that it's a hidden object, so it contains config, and it actually is the JSON that is used by Kubernetes is generated down here. But let's take a look at that object and see what we're actually doing. So in the Prometheus library, you can see a number of top-level objects. There's a config object. There's also a Prometheus object, which has all of the configuration for Prometheus itself. So you can see service account, you can see role bindings, and then there's service monitors. And all we're doing is we're adding a service monitor to this JSON object. So if I go back to my nic.jsonit, you can see the Prometheus object there. The plus means concatenate, so we're adding to it. And then you can see that we're adding this service monitor SuperDuper. There's the key, and then this is the new object. And it's a service monitor custom resource. And you can see that the actual way that it tells Prometheus to monitor something is this match labels. It has a selector, and we're matching labels on app SuperDuper. And then we're looking for the endpoint, which is the port named web. We're gonna refresh every 10 seconds. So I'll go ahead and add that. So we're gonna have to rebuild, and let's restart. Okay, so it looks like it's finished. So now we're going to go ahead and apply again. Great. So now at some point in the next, hopefully 10 seconds, we should see another service come up. Okay, so it looks like we see SuperDuper now. It's just started emitting metrics. So let's zoom in a little bit more. Great, okay, so okay, so I also wanted to show some of the rules that they've actually included. So if you look at inside the Prometheus library, you can see some rules that they've actually already added. For example, you have an instance node CPU. You have file system usage, you have a couple network metrics, and so let's take a look at those, and it's a really easy way to get started. So we can take a look at, for example, node saturation. And so you can see the CPU saturation is really quite spiky right now, and that's probably due to the extra load that the metrics, like Prometheus, is putting on the system, as well as the deployment and the requests that we've been sending at it. So let's take a look at utilization and see how that compares. Huge spike in utilization when I sent the requests to SuperDuper. Disk saturation and utilization as well. So I wouldn't expect too much disk saturation. Looks like there is some. And then disk utilization. Cool. So yeah, I think this is a really easy way to get started with Prometheus. It makes it very easy to add your own configuration, but also gives you a lot of really useful tools just to get up and running. So yeah, if you have any questions, feel free to ask them in the chat, and I hope you enjoyed the presentation. Thank you so much. If you're interested, check out these references. There's the read method, the use method, a great video by Bob Cotton about Kubernetes Metrics, and thank you.